Hello, I am Engineer Larry Jean Kaime, mechanical engineer by profession, and currently working as a building optimization operator analyst in ISH Business Solution. And I will be your instructor for mechanical engineering refrigeration system. Our reference for this subject is Refrigeration and Air Conditioning by Wilbert Stocker and Gerald Jones. The learning outcome for this discussion is to learn about the basic principle and theorems of refrigeration system. The learning objective at the end of this discussion, you will be able to understand the basic refrigeration system and be able to analyze and calculate simple problems. Refrigeration is a branch of science that deals with the process of cooling of a space or substance below the environment temperature. It applies in food processing and preservation, chemical and other process industries that requires controlling right temperature, cooling to condition certain operations, and industrial air conditioning, and even for comfort. Refrigerating, there is a fluid form that helps or responsible for cooling. Now, what is refrigerant? Refrigerant is a primary working fluid used for absorbing and transmitting heat in a refrigeration system. It absorbs heat at a low temperature and low pressure and release heat at higher temperature and pressure. Most refrigerants undergo phase changes during heat absorption, evaporation, and heat releasing condensation. Now let's talk about the cooling load product. The first type of product load is often called the product cooling load, and it represents the amount of heat that must be removed to take a product to its freezing point temperature. The second type of product load is the freezing load. Once a product has been brought to the freezing point, the additional amount of heat that must be removed to actually freeze the product depends on the product latent heat of fusion. To take a product below freezing, a quantity of heat must be removed according to the product specific heat value and the desired final temperature. This third product load type is often called the sub-freezing load. Finally, if a product undergoes respiration, as in the ripening of fruits and vegetables, then the heat given off by this chemical reaction is called the respiration load. The sum of these four loads component is considered as the total product load. Let's solve the sample problem number 1. What is heat needed to completely vaporize 100 kg of ice at negative 10 degrees Celsius if the pressure held at 200 kilopascal? Latent heat of fusion at 200 kilopascal is equal to 320 kilojoules per kilogram, and the latent heat of vaporization at the same pressure is 2,202 kilojoules per kilogram. To get the heat needed, we must calculate the Q1 respect to the freezing temperature of negative 10 degrees Celsius with the specific heat of ice 2.093 kilojoules per kilogram Celsius. Q2 is the fusion process of ice to liquid at 320 kilojoules per kilogram with a specific heat of water 4.187 kilojoules per kilogram. And the Q3 is the vaporization at 2,202 kilojoules per kilogram. Using the cooling load or the total cooling load product, we can get the 296,163 kilojoules, or we can say it is 296.1 megajoules. Now we will talk about mechanical refrigeration. Mechanical refrigeration has basic four components. One is the compressor. Compressor is known as the heart of refrigeration system. It compresses refrigerant vapor and causes it to flow in the system. Because of it, it circulates the refrigerant through the cycle. Second is the condenser. It is a device that transfers heat out of the refrigeration system to a cooling medium, which is either air, water, or a combination of both. Next is expansion valve. It reduces the pressure of the refrigerant so that low temperature will be attained and regulates the flow of the refrigerant to the evaporator. And lastly, the evaporator. The liquid portion of refrigerant evaporates while absorbing heat from the surrounding. Most important refrigeration cycle is the vapor compression cycle. It is the most widely used in refrigeration cycle in practice. In this cycle, a vapor is compressed, then condensed to a liquid, following which the pressure is dropped so that the fluid can evaporate at a low pressure. With this, there are two diagrams involved in this system. The pH diagram. To plot pH diagram, at y-axis, we have the pressure, and at x-axis, we have the enthalpy. Now that we already plot this axis, the curve represents the saturated line. What you are looking right now is the skeleton of pressure and enthalpy diagram, or the pH diagram. As mentioned, the curved line is the saturated line. At the left portion is the liquid line, and at the right portion is the saturated vapor line. And the rest of the curve represents the behavior of. Now let's talk the processes involved in the vapor compression cycle. In point 1 to 2, there is an increase of pressure and enthalpy, which is we call it isentropic compression in the compressor. The process 2 to 3, there is a constant pressure condensation in the condenser. And the process 3 to 4 is the asynthalpic expansion and in expansion valve, where there is a drop of pressure while maintaining the enthalpy. And in the point 4 to 1 is the constant pressure, vaporization, and the evaporator. Now let's get the compressor work. When we get the compressor, we will check the process between point 1 and point 2. And we will get the H2 minus H1, and that will be our compressor work. Next is the heat rejected in the condenser. We will get the heat rejected condenser by getting the values at process 2 to 3, and we will get the QR is equal to enthalpy at point 2 going to enthalpy point 3. Next is for the expansion valve, or considered as throttling process. Basically, we can get the value by getting into the steam table and doing the interpretation if it is not available, where X is the quality of weight of flash gas per unit weight of refrigerant. Now let's get the refrigeration effect. It is the QA from point 1 enthalpy going to the point 2 of enthalpy, and we will get the tons of refrigeration by dividing it to 3.51 kilowatt. Before we proceed to the sample problem, I want to remind you that in every refrigerant there are designated pH diagram. Sample problem number 2. A standard vapor compression cycle developing 50 kilowatt of refrigeration using refrigerant 22 operates with condensing temperature of 35 degrees Celsius and an evaporating temperature of negative 10 degrees Celsius. Calculate the following. This is a sample of pH diagram for refrigerant 22. There are given values in the problem, and what I did is I plot them to get the enthalpy from the given temperature. Since there is an available pH diagram of refrigerant 22, we already had the values of enthalpies, and we can now solve for the refrigerating effect. Please do note that
as I mentioned,
in some instances, there are also tables that can provide you the values of enthalpies. Now let's proceed for the other problem. For B, we can get also the flow rate once we already have the refrigerating effect. Now we had the answer for the flow rate, which is 0.0 315 kilogram per second. Next is the power required by the compressor in the work of compression per kilogram multiplied by the refrigerant flow rate. Please note that we already had the flow rate. Now we can multiply it from the difference of the two enthalpies from point 1 and point 2. Now we can get the 10.6 kilowatt. Next is the coefficient performance is refrigerating rate divided by the compressor power. We already have the refrigerating rate and the compressor power. Now we can get the 4.72. For the volume flow rate, the compressor inlet requires knowledge of the specific volume of refrigerant at point 1. That can seen in the provided table of pH diagram in R22 or even on the table. So we can get the volume flow rate of 0.026 cubic meter per second or 20 liters per second. The compressor power per kilowatt refrigeration, which is reciprocal of the coefficient performance in the power of refrigeration, is now 0.212 kilowatt per kilowatt. And for the compressor discharge, the temperature is the temperature of superheated vapor at the point 2, which can be found at the R22 table or pH diagram, and that is 57 degrees Celsius. These are also the exercise problem that I prepared for you. In a whole bond A4 paper, please answer the following exercise problem. How was it? I hope this subject will give you an excitement to learn more about mechanical engineering. Till next time, and thank you for watching.